Thanks so much for the short introduction. Myself, I see many faces here. It's really nice feeling. My name is Wojciech. I'm a software developer, software engineer in Monterail for over 5 years. During this time, I spotted many situations where developers are struggling with writing a test for their code, and this was my main motivation to prepare this talk. I'm going to start with defining what a test double is, when it's worth to consider using them. After that, we'll take a look at a proposed classification of test double, and finally we'll focus on example using the spec, using our spec. Okay, so what is it? The test double is a broadest term for any kind of pretend object which could be used instead of the real object for testing purpose. This is the one of the definition. I also spotted that this term is also used to describe a set of practice, set of techniques which are related to using this fake object instead of the real one for the testing purpose. So we have this two definitions. And the origin of the term is also interesting. It comes from the stunt double in movies. Here on this screen, you can see the scene from the Matrix Reloaded. And you can spot here a stunt double, Debbie Evans, who is stunt double for a Trinity character here. So you can think about analogy between the test double and stunt double. It's something what can be used instead of the real object in our test. Okay, so let's try to say when words to consider using this test double. The first thing which comes to my mind is using them in unit test, because we would like to test units in isolation, right? Real systems looks like on the left side, we have many units which communicate each other, but we want to test one particular unit, and to do it quite in a quite simple way, we want to replace the old dependencies, and instead of the real dependencies, put there something simpler instead of them, right? And here is a place for the test doubles. Another situation is when we not able to use the real object in our test. And I can imagine that it could be when our code rely on something really dependent on the hardware in testing environment, which is not possible to have it there, or it could be something such simple like current time. Our code could rely on the current time on the machine when it's running, right? And here also the test double could help with it. Yep. And there are many more situations. There are some situations when you can use the real object, but if you use the real object, basically it will lead to significantly slowing down the performing this unit test and performing the whole test suite, right? So it's not maybe reasonable for some situation use the real object here. The great example here is using, for example, something which will be a replacement for a real database. For this purpose, you can use in-memory database, because calls to DB could be time-consuming operation here. Another thing is calls to external services. There also could be time-consuming, and any other things which under the hood triggers some side effects which are time-consuming, like processing images, etc. And this situation probably is even more. Okay. Right now, I will try to present a classification of test double. I'm going to follow the vocabulary of Gerard Meszaros. He's an author of many books related to a unit testing topic. So this classification is his idea. At first level, we can split this test double into two sets, let's say, stubs and mocks. The stubs, generally, it's something which mimic the real object, but it's simplified implementation. And amongst the stubs, we can distinguish something like dummy object. Dummy object is an object which is put into some method as an argument, just to fill the argument list, right? To avoid argument error in Ruby code. Amongst the stubs, we can also can distinguish the fake object. Fake object is just a simplified implementation or of real object with little or no side effect. It's definitely faster than actual implementation due to this. A great example of fake object is in-memory database, which I also mentioned before, instead of using the real quite complicated external database. Okay, and we have also a stub. Stub provides cannot, previously recorded, previously defined answer to calls made during the test, right? So we can define that stub, if receive a method A with argument 1, will return, for example, 2 as a result of this operation. But if the stub receive any other method or method A, but with a different argument, and we don't predefine it, we don't record, we don't include in the stub the definition this, then basically it won't return it, and it will lead to an error. And the second group of the test double is mocks. And here mocks are more concentrated on the message expectation, which comes to them from the unit which we test in our test, right? Here we can distinguish two test double, the spy and the mock. The spy are stubs that mostly focus on recording information based on how they were called, right? So basically they register everything what comes to them. If we invoke on spy method A with some argument, it will be recorded. If we invoke another method with another argument, it will be also recorded. Example, an email service that record how many messages it was sent, and after that we can in test assertion can check if the number of sent email was equal to what we expected to be done, right? And we have a mock, and mock are more strictly here, and they also register calls they received, right? But they are pre-programmed object with expectation, which form a specification of the calls they are expected to receive. So generally, we need to define what mock is allowed to receive, and if mock receive anything what is not expected before to receive, it basically throw an error. We can also use a mock in that way that we define a set of methods which we expect to receive, and if one of these expected invocation haven't been performed during the test, it will also raise an exception. So similar to spy, but more strict generally, can throw an error if something unexpected will happen with them, and also can allow stop some a fake response to predefined method, right? Okay, and right now is a time for presenting some example. This example will be, this example have been made by myself. I use here a RSpec framework, and basically I use everything what this framework provide out of the box. I also don't want to overwhelm you by presenting the whole classes and whole unit test, so I decided to excerpt just some parts of the code of the classes, code of the unit test, to highlight on most important things. My aim here in this part of the presentation is to show you how you can use test double provided by this library, I mean RSpec, yeah, and show the general approach to do it. Let's start with stub. So regarding previously showed classification, here we want to deliver a simplified version of real object, right? In order to do it, we will go with the double offered by the RSpec. On the left side of the screen, you see a class which will be under the test. Here is a currency converter. As you see, there is a initializer which receives an instance of the real lookup, as you see, and has one public method convert to PLN, with two named parameters, amount and currency. And let's try to test the currency converter. The real lookup class, which is a dependency for currency converter, has one method, getRate with currency argument. The real implementation behind this method, I mean the body of this method, could be really complicated, could call some external services, could contain really complex logic. We don't bother about it. We would like to provide something which will replace the original object. We would like to provide a test double for real lookup, right, as a dependency to the currency converter. The subject in our test is currency converter instance, right? But we create this instance by injecting lookup, which is a fake lookup. And to define a fake lookup, we not create an instance of real lookup, but we use a method double from the RSpec library here, and we provide a string which is a name of this double. This allows us to define some behavior for this fake lookup. Especially, we would like to allow the fake lookup to receive invocation of getRate method with some argument. Here is a euro, right? And if the fake lookup receive invocation of getRate method with this parameter, it return this value 4.58, right? We can also allow to receive the fake lookup method which is called not existing method and return true. It's allowed because we use a normal double here, right? We use this double to use this instead of the real object, right? It should be enough to test the logic of the currency converter. Everything so far went fine. If somewhere in the code we invoke the fake lookup, the method getRate on fake lookup instance with parameter euro, basically it returned 4.58 as we expected because we defined it in the before section. If we invoked this method but with another argument, basically it will throw an error that fake lookup received getRate with unexpected argument because we haven't defined it in the before section, right? The double doesn't know what to return here, so writes an error as we expected. And finally, thanks to that, we can test the public method of currency converter, which is called convert to PLN. For this invocation, we'll get 45.8. This is just the rate multiplied by amount, right, as we expected. But if somewhere in the test we invoke the convert to PLN method with different currency, which is not defined on the double object here, we basically will get the error here, right? So the test failed shortly. Next to the normal double, RSpec offer verified double. The code under the test is the same on the left side as in the previous example, but here we use another method from the RSpec library, not the double, but the instance double. And as an argument to instance double, we provide a class which instance we would like to mimic. We would like to provide something which basically behave like a real instance of the real lookup class, right? So here is a reason why we use instance double. And again, we allow to define response for method getRate with the euro argument as before. But if we try to define a response for method which is not implemented by the real class, basically, the library writes an error and inform you that real lookup class does not implement the instance method, not existing method. So basically, if you go with the double, basically you can introduce into your test something which comes from your fantasy, right? And it's not related anyway with the real object which you stop, right? Here, if you go with the instance double, okay, you can stop the response for this method for particular method with particular argument, but additionally, it also takes care of checking if this instance double for real class, right? Check if this real class indeed have this method with this signature, right? If not, then basically it writes this error. So it's nice to use something like that in some cases. Next to instance double, RSpec also comes up with something like class double, which allows you to stop not the instance method, but class method. Something like def self dot something, right? So if you need to stop the class method, you can go with the class double method from the RSpec library. Okay, you can also define a stop using a real object. And here, let's go with this weird implementation of real lookup, where getRate method, regardless what argument you put, always return 1. And the second method, getYesterdayRate, with whatever you put, return 0.99. And this time, let's use the real object, the real instance of the real lookup class. But you still can stop a method on this real object. For example, I can stop a getRate method on this instance of real lookup. If this method will be invoked with euro argument, it will return 4.58, right? Okay, it's fine, everything fine. If somewhere in the code I will invoke this method on the real lookup, it will return 4.58, right? But if I invoke this method with something what haven't been defined in the before, it basically writes an error that received getRate with unexpected argument, because we didn't explicitly define what should be returned by default by this method if the argument will be different than euro, right? On the other hand, if we invoke another method which we haven't stopped in before block, right, we can use the original implementation of this object. And here you can spot that it will return 0.99 as in the original implementation in real object. Side note, the USD here, it's not needed because the implementation of the method doesn't use it at all, right? So this is a great example of dummy argument, which you need to put it into the invocation of the method to avoid the argument error, right? But it's not used by this method, right? So this is a dummy object, which is also a test double. We have also something what is called a spy. Let's go with this example. We have a report generator. This report generation has a dependency which is a mailer. This report generator has one public method, send notification, which has only one argument. This is email. Let's try to use spy here. And our subject is, again, report generator instance. In place of the real mailer, we provide fake mailer. And fake mailer here, we define using the spy method from RSpec. So it's not double, not instance double, and so on. We use a spy here. And basically using a spy allow to invoke on this spy whatever method we want with whatever argument we want. And basically it won't arise any error, right? So this is legal. And basically it's return nothing, but it not rise any error, right? This object, as I previously said, are designed to record what they have received during the test, right? In our case, we would like to check if the email will be sent, right? We can do it in that way. Just imagine for a moment there's this line with the subject dot send notification and argument with email is uncommented, and we have such expectation. Expect fake mailer to have received sent with email, and basically if we uncomment this line with the line which contains the subject, right? Basically the test will pass. If we uncomment if we comment this line with the subject send notification as it is on this line, right? But we put this expectation, then basically it informs you that we expected to receive something, but it haven't been performed during the test, right? So this is a purpose for spies, recording what is incoming, like a method invocation on spies, right? And check some expectation, message expectation. We can use also mocks for similar purpose. The code on the left side is the same as in the example with the spy, but we can use here a mock instead of the spy. And let's do it using the class double method from the RSpec. And we can define in the before that the fake mailer, if received the send, it return the true. So this assertion in our test basically will pass because the subject sent notification email return something what will be returned by the mailer by the send method on mailer object, right? But we use as a mailer a fake mailer, which is a class double, and we mock this method sent on this class double, right? So everything fine here. And we can also check if the method sent have been invoked during the test. In that way, expect fake mailer to receive. And if we uncomment the line with the subject.send notification email, basically the test will pass. If we leave as it is, I mean commented this line, that basically it will trigger, this will raise an error that we expected one time receive with argument this, but we haven't received, right? So mocks also allows you to do some checks regarding what's coming to them, and also allows you to stop the method, right? Yeah. And I think it's all related to the most interesting thing regarding test double in RSpec, but I feel in duty to inform you about some other tools, some other library which is worth to consider during writing some test, regardless if it's unit test or integration test, like helpers in active support testing times helpers. This is provided by the RACE, and this helpers allows you to simulate the current time in the system is different than it's real, right? So, for example, we can somehow simulate this. Today it's 1st January because some logic on 1st January in our code behaves different than on any other days. We can also use a time cop for similar purpose. I mean, mocking the current time in the system. This is a gem, Ruby gem, which can be used. The another set of tools which is worth to mention here is webmock and VCR gems, and they could help you with stubbing a HTTP request. For example, your application or part of your application rely on some external API, but it's not possible to test it, or you don't want to test it during performing the test suite, right? Due to many factors, like, for example, just really long time needed to do it, right? So we can define that if such request will be generated by our application, regardless what library we use for creating HTTP call, if it's Faraday or REST client or anything else, it will return, it will simulate that we receive some response from the external service without calling the real service outside our application. So I think it's worth to mention these tools. And yeah, I think it's all from my side here regarding the test double. If you have any question, feel free to ask them now, or you can even try to reach me later, and we can discuss some topics from this presentation. Thanks.